So this is kind of where we ended yesterday. This may not be exactly what was written down in here. It's just what was left over from the last class. But I'm not sure. In each class, I had a different amount of time to talk about, let you think through it and talk about the possibilities or whatever. So I just kind of want to start from scratch with this, even though all these are already written up there, and talk about it again. I want to make sure that you understand why this one right here is not a possibility. We don't find the surface area of both of them and then subtract. Okay? If you've done composite figures before, or three-dimensional figures, then it's been most likely just with volume. Highly unlikely you did any composite figures with surface area. Okay? So volume-wise, if I was going to find the volume of the composite figure, yes, then I would find the volume of both and just subtract it like that. All right? Does that make sense as far as volume goes? Because it's like it's solid. But for surface area, you really want to think about it as being empty. And so I'm not subtracting a cylinder, because if I there's not even a cylinder in an empty box for me to take out to begin with. All right? When you take the cylinder out as far as volume is concerned, you actually now have less volume but more surface area, right? Because now I have a surface in here that I could touch that I could not touch before. All right, so think about cheese, okay? So I have two slices of cheese. They're the same thickness and the same size. Got a slice of cheddar cheese, and I have a slice of Swiss cheese. Y'all know what Swiss cheese is? The one with the holes in it, okay? So as far as the cheese itself is concerned, which slice of cheese actually has more cheese? The cheddar cheese, right? Okay, so the cheddar cheese has more cheese to it because it didn't have the holes in it, but which slice has more surface area? The Swiss cheese, because there's more surfaces that you could touch on the inside. Does that make sense to you? So yes, there's less stuff in this picture as far as volume is concerned, but there's more surfaces to touch. Cooling and heating coils are coils really for that reason, or sometimes things like zigzag back and forth for radiators or whatever, because instead of just being like one big tube that could radiate heat, that's just coming off of one single surface, where if it zigzags back and forth, even though it may be thinner, there's a lot more surface for it to come off of to radiate the heat or the cooling or whatever else is happening. Okay, so sometimes it's important to have more surface area and less volume or whatever. All right, so let's talk about these other ones. Now, when you think about, you can think about these two different ways. From a standpoint of finding everything you need and then taking off what you don't need, or kind of building it from scratch. And different ways work differently for different people. It's just whatever makes the most sense to you. But the default way, the way everybody needs to be able to understand it, and the kind of your go-to way when they get confusing, is to find everything and then take off what you don't want. Okay, so if you can identify on here that this is a triangular prism and a cylinder, right? So we'll start by finding the total surface area of both things. Now you're gonna have to pretend like this box that I have is really a triangular prism, because the shape really doesn't make a difference here. But so if I'm gonna I have this box and I have this cylinder, right? So I'm gonna put the cylinder inside the box. I'm not actually gonna do it because then you couldn't see it. So you have to pretend like it's on the inside. So if I find the total surface area of both of them and put them together, right, then clearly there's some stuff I don't want, right? That's a problem, because I need to be able to get into this tunnel and walk through. Because remember, I know that these pictures are not fantastic, but this is like a tunnel. I can start here and walk all the way through and come out the back. All right? I know it really doesn't look like it's empty. Some of them aren't going to look that way, but that is the intention there of that picture. So I need to be able to actually walk through that cylinder. So if I take my cylinder and I put it inside the box, can I actually get into the cylinder yet? No. So I need to take the ends off the cylinder, right? So now my cylinder is like a tube, like a tunnel, yes? But it's inside the box. So even though I took the ends off of the cylinder, I still can't get in the box, right? So I have to kind of circle out on this side to get in, and then a circle out on the other side to be able to get out. And that's why you would find both of the total surface areas, and then you have to take off 4 circles. Does that make sense to you? Or you can think of it as, all right, so I have the box, and I need the tunnel. So I have a tunnel, which is like just the lateral area of the cylinder, and I can put that inside the box. Well, that's great. I got my tunnel in there, but again, I got to be able to get in, and so that's why I have to subtract these 2 circles here from the box itself. Okay, we okay with that? Now, these two things right here are really the same thing, just written in a different order. The one in pink is the order in which somebody said it to me. Like that was basically their thought process of how to do it. So we'd find the total surface area of the prism. I'm going to cut the two holes in there. Now, what if I stopped there? What if I just had the prism and I cut a hole in each side? Then what happens when I walk through that hole? I'm going to fall to the bottom. There's nothing, a floor there for me to stand on, right? Here, I guess there kind of would be. You wouldn't really fall, but you'd be able to kind of come over here in this part where you would really be able, you shouldn't be able to get to. So, yes, I'm going to cut the two circles out, but then I have to think, all right, well, when I do that, I'm still missing the cylinder, so I have to add it to it. So these with the holes in them are tough at first for some people because it's hard to think about, why am I adding that when I'm really taking stuff away? Well, you are taking something away, but you're also adding other surfaces to it. Okay, does that help a little bit? Good. And then the one that is like above it, I think, what's the picture was? I forgot. Yeah. So these up here, remember that these are always open figures, meaning that when I put these together, the cylinder and the box, there's never a floor there. There's never a floor or a shelf here, even if it might kind of look like it in the picture. Think about it as if it's like a two-story house, it's not really a two-story house. Because in a two-story house, if you're standing on the first floor and there's a bedroom above you, then you can't see the top of the ceiling or the top of the second floor, right? There is no second floor there. I can freely go from the box up to the cylinder and back down. There's no shelves or ceilings or anything in there, okay? Are we good with that? Any questions? No, not without. So his question was, so basically, would there ever be anything where it's like this, but there really is a wall right there? Is that what you're asking? Yeah. No, not unless it specifically said that in the problem for some reason, if they were trying to get you to a certain direction, but not on the question where it would just be like this and you're expected to just know that it's there. Okay, so that, because I know that it's really kind of hard to shade them even when these are pretty well done, but I don't know how else to make it different, just to know that they're the same all the time. Mm-hmm. Yeah. Yeah, so for volume, for this, it'd be easy. Volume, and you add them together, right? That's when you're thinking of them as being solid. But when you're talking surface area, it's if I'm holding this thing in my hand, what can I touch? It's literally the area of the surface area. Okay, what you could paint if you were going to paint it like that without taking it apart. Okay, we good? That's why you can't, for surface area, you can think of them as being solid, like fully solid, like this was a big chunk of wood or something, then what part could you paint? And that's why I have one of these little, this one right here where it's kind of purples, because I always say, pretend like this thing was purple to begin with, and then I painted it all blue, right? Then I took the cylinder out. Well, guess what? I wasted some blue paint, right? Because that was 2 circles of blue paint I didn't need, and now I have still some more purple that I have to paint to it. So you can still kind of think of it as being solid depending on how if you're thinking about them as boxes or chunks of wood, that just, whatever makes the most sense to you to wrap your mind around. Okay. Oh, okay. But I can't get to the inside because it's closed. You don't get to open it up. Does that make sense? So I see what you're saying there. So his question was, why don't I multiply it by 2? Because you can paint the inside and the outside. But remember, these are closed. You don't get to open it up. All right? So you're not opening it up. It's just on the outside. What could I touch? Okay, that's a good question. Did you have a question? Right, then you wouldn't paint the floor. Yeah. So yes, that's a good question. So he said if it's everything you can paint, then if it's like a barn or something, are we doing the floor? Well, if it's a figure like this that isn't really anything and I can like pick it up and hold it, then it's everything I could touch. But yeah, when you're talking about paint or you're going to cover something, you have to think about, am I covering the bottom? Does the bottom count? Does the top count? Or that sort of thing. So in a real life example, you're going to have to take those things into account. But just the generic figures, then don't overthink those. That's a good question. All right. Anything else? Okay. One other thing is that, so when I give you what you're going to do today, and I've been checking people's plans, well, when they come up with their plan, let's say that it was, I don't know, I'm going to draw another picture here. Let's say we had a rectangular prism, and then there's like another one on top. I probably shouldn't even have tried to draw this freehand, just off the top of my head. Okay, this is what I get for trying to wing something. Let's say that it looks like this, but a whole lot better. Okay, so just pretend like that works, right? Pretend that it's like that. And maybe I should have just said on the other one, instead of a cylinder and a prism, that it's two prisms. Pretend like those are two prisms, okay? And there's two like the same. They're two rectangular prisms. If you're going to tell me you're going to find surface area, and subtract something, you can't just tell me it's the surface area of the rectangular, oh my God, rectangular prism plus the surface area of the rectangular prism, right, minus whatever, because there's two of them, which is which. So you can handle that however you want. Big and little, 1 and 2, A and B, whatever. Just make sure that you're distinguishing between the two. Because what I found on a couple people's plans is when I asked them, I kind of assumed I knew what they meant. I said, is this what you mean? Is this what you mean? Yes. But then they would have like, then something that was in there, they weren't even sure. And I think when you get to the end, you're going to confuse yourself. So, so I could name them 1 and 2 if I wanted to. So I could say, you know, surface area of 1 and 2, or even if you just did that, surface area of 1 plus the surface area of 2, and then there's more stuff that goes with there. But however it works for you, and it doesn't have to be just like mine, it doesn't have to be like just like your neighbors, but if you have more than one of the same figure, make sure you're distinguishing between the two things, or the three things, or whatever they are. Does that make sense? And whatever makes the most sense to you. I'm not going to dictate that. It really doesn't matter. As long as I can come and read your plan and understand it. All right. Any more questions about that? Any of this, because those are good questions. Just ignore my horrible pictures here. All right.